Welcome to our channel. Today, we're diving into the fascinating world of scalability testing, an essential aspect of software testing that evaluates a system's ability to handle increasing workload and user demand while maintaining optimal performance. Join us as we explore what scalability testing entails, its significance in ensuring software growth without compromise, and best practices for effective implementation. Let's get started. Introduction to scalability testing. Definition: scalability testing is a type of performance testing that assesses a system's ability to handle growing workload and user demand while maintaining performance, reliability, and responsiveness. Purpose: it aims to identify performance bottlenecks, assess system capacity limits, and ensure that the software can scale effectively to meet future growth and user demand. Types of scalability testing. Vertical scalability involves increasing the system's capacity by adding more resources, such as CPU, memory, or storage, to a single server or instance. Horizontal scalability involves distributing the workload across multiple servers or instances to accommodate growing demand and achieve higher throughput. Load balancing ensures even distribution of incoming requests across multiple servers or instances to optimize resource utilization and improve scalability. Objectives of scalability testing. Assess scalability limits, determine the maximum workload, user concurrency, or transaction volume the system can handle without performance degradation or service disruption. Identify performance bottlenecks, pinpoint scalability bottlenecks, such as CPU saturation, memory exhaustion, database contention, or network latency, that may impact system scalability. Validate scalability mechanisms. Verify that scalability mechanisms, such as load balancing, caching, or horizontal scaling, are effective in improving system performance and scalability. Plan for future growth. Provide insights into the system's scalability limits and capacity planning requirements to accommodate future growth and user demand. Best practices for scalability testing. Define realistic scalability goals. Establish clear and measurable scalability objectives based on anticipated user growth, workload patterns, and performance requirements. Design comprehensive scalability tests. Develop scalability test scenarios covering various workload levels, user concurrency, data volume, and transaction rates to simulate real-world usage patterns. Utilize appropriate testing tools. Select scalability testing tools and frameworks that can simulate realistic user behavior, generate meaningful workload patterns, and provide comprehensive performance metrics. Monitor system metrics. Continuously monitor key performance indicators, such as response time, throughput, resource utilization, and system capacity, during scalability testing. Analyze scalability results. Analyze scalability test results to identify performance bottlenecks, scalability limits, and areas for optimization or improvement. Scalability testing process. Test planning. Define scalability test objectives, scenarios, and performance criteria based on system requirements and anticipated user growth. Test design. Design scalability test scenarios and test cases covering various workload levels, user concurrency, data volume, and transaction rates. Test execution. Execute scalability tests using appropriate testing tools, simulate workload patterns, and monitor system performance metrics. Performance analysis. Analyze scalability test results, identify performance bottlenecks, scalability limits, and areas for optimization or improvement. Optimization and planning. Implement scalability improvements, optimize system configurations, and plan for future capacity requirements based on scalability test findings. Challenges in scalability testing. Realistic workload simulation. Simulating realistic workload patterns and user behavior that accurately mimic production environments can be challenging. Resource constraints. Provisioning test environments with sufficient resources and infrastructure to support scalability testing can be complex and resource-intensive. Data management. Generating and managing large-scale test data sets for scalability testing can be challenging, especially for systems with complex data dependencies. Tool limitations. selecting and configuring scalability testing tools with the necessary features, scalability, and compatibility with the application under test can be challenging. Conclusion: scalability testing is crucial for ensuring that software applications can handle increasing workload and user demand while maintaining optimal performance and reliability. By following best practices and leveraging appropriate tools, organizations can identify performance bottlenecks, optimize system performance, and ensure that their software can scale effectively to meet future growth and user demand. Stay tuned for more insights into software testing methodologies and best practices. Thanks for watching. Please subscribe our YouTube channel.